Hi, this is the Fuel Science 431 group project for Group 2, being narrated by Shaunak Pillay. We have chosen to do our project on the engineering of kerosene. This body of work has been presented by Zai Zhang, Abdullah Zoghbur, Nick Appling, Ronaldo Springer, Joel Luckenbau, and Shaunak Pillay. Thank you and enjoy. The Origin of Kerosene by Nick Appling and narrated by Shaunak Pillay. In the year 1846, medical doctor and geologist Abraham Gesner produced a clear fluid by distilling coal. He noticed that when fluid was placed in a lamp with a wick, it burns with a bright yellow flame, much brighter than burning oil. He named the fluid kerosene, from the Greek keroselion, which means wax oil. The process of extracting kerosene from distilling coal was too expensive to be viable, until it was discovered that kerosene could be produced from petroleum, which is more affordable in mass-scale production. When kerosene was originally produced, it was primarily used in lamps. The first modern kerosene lamps were invented by Ignacy Łukasiewicz, an inventor from Poland, and Robert Edwin Dietz from USA, at the same time independent of each other in the year 1853. Now we will talk about kerosene over time. During the fuel crisis of the 1970s, a brand called Saab Valmet developed and series-produced the Saab 99 Petro, which is a car that ran on kerosene, turpentine, or gasoline. Kerosene has also been used to power smaller horsepower outboard motors, such as those built by Yamaha Motors, Suzuki Marine, and Tohatsu. Kerosene has also been used to prevent air from redissolving in a boiled liquid. In the early 20th century, kerosene was seen as a cheap fuel for tractors. Kerosene has a wide variety of utilities and is the most useful of all fuels.
Hey, my name is Abdullah Zoghbur, and I will be talking about the manufacturing process of making kerosene. Now, the first step to producing kerosene is to recover oil. This can be done by extracting oil using different drilling methods. However, I will focus on the three primary ones used today. The first one will be the cable tool drilling, which is one of the first ever used and dates back almost 4,000 years ago. It is used for extracting oil from beneath the Earth's surface, of which isn't too deep, and that's done by having a steam engine power the entire thing, by using the cable to raise the heavy end or blunt chisel and repeatedly hit the ground with it. While this is the cheapest way and most fuel-efficient of methods, it doesn't produce enough fuel compared to the other two methods, and it's just an outdated technology compared to the other two. Now, the second one would be the rotary drilling, and it is the most common type of drilling, which is used to reach oil reserves that are deep. The process has to do with having a drill pipe with a rotating steel into the ground. The rotary drill spins and technically pulverizes or breaks the ground. And this method is much more efficient than the previous one. However, it has a higher cost in general, and that's based on just the fact that it produces more oil. Finally, the offshore drilling. While it technically follows the same thing as the rotary drilling, but instead of it being onshore, it's offshore. And it is the most expensive procedure, technically most expensive method. However, the most rewarding, as it has like the most technically volume of oil that can be produced compared to the other two methods. So yeah, and then from there onwards, we go on to the crude oil distillation unit, and basically what happens is they go to petroleum refineries, and the first process is known as distillation. And in that process, what happens is crude oil is heated and fed into a distillation column. And as the temperature of the crude oil in the distillation column rises, the crude oil separates into the 8 petroleum products, or different components, which are called fractions. And the fractions are then captured separately, each at its own boiling point, you could say. And for our case, which is kerosene, it boils between 350 to 450 Fahrenheit, and it makes it the fourth product out of the 8 products that are made from the crude oil distillation unit. Now, while we do technically have kerosene right now, it is not at its finest or most purified state, and this is where the purification of kerosene comes into play. Once we obtain kerosene, additional steps are required to remove the contaminants that can have an impact on like the oil burning properties of kerosene. And technically what has to be removed for that to happen are the aromatic compounds, and that's done by maximizing the contact time between kerosene and the extraction solvent. The reason why we do that is because the extraction solvent technically has the impurities dissolve in it or react with it first. So all that has to be done is basically repeat that step over and over again, where we add solvent, and that solvent takes the impurities out, and then we separate them both over and over again until we get like the most purified state possible. Now, with that, with having to do that step, waste occurs. And from that waste, instead of just disposing it, this is where a byproduct can be made from it, and that's paraffin. And just like what's written on the slide, it's a wax-like solid that is a mixture of saturated hydrocarbons, which are created by the distillation from petroleum, and specifically in our case, kerosene. Now, paraffin can be used in basically candles and waterproofing compounds. So yeah. Finally, the future of kerosene. Now, in my opinion, or at least as a group, we do not see kerosene playing as much of a role or as big as a role in the future, in the far future, just because of how electric vehicles or electric planes might take over, because they do have a faster response rate to torque, and that is what's needed in technically fighter jets. However, in the closer future, you can say that commercial aviation may benefit, just like what's written on the slide, by reducing the risk of jet fuel explosions by creating a new low-emitting kerosene. And in the residential sector, new and improved kerosene heaters that provide better protection from fire are anticipated to increase demand. But
quality of the kerosene. There's high quality kerosene. It's looking like this bottle. It's clear. You can see through that. And then good high quality kerosene always properly stored in pouch airtight container or tank. Also stored in cold dark location. And the second bottle, that one is kinda like have some water in there or sediment in there. It's okay. And then third bottle is really poor quality kerosene. It's cloudy, you cannot see through that. There's a lot of water and sediment in there, and then poor quality kerosene, or always improperly stored in direct sunlight over high heating place. Water and sediment are most main type contaminant of the fuel, and water is the most common one due to a temperature change, condensation more on the fuel. And any water can cause icing in the aircraft fuel system and the closure of fuel system component. Sediment usually come from such as tank, pipe, being pump holes, and any other component that contact the fuel. And any sediment can cause mechanical problem of the aircraft engine. On the picture you can see that the water is on the bottom and sediment is on the bottom and kerosene is on the middle. That's because the special gravity, because the kerosene is lighter than the water and sediment. So when you use the kerosene, you use the fuel on the top. There are 7 ways to remove water and sediment from kerosene. The first one is use strainer, but this is the most common one. Yeah, but this only remove sediment, cannot remove any water from the kerosene. And this machine is called purifier, and this machine is called filter separator. They are both can remove 100% of the water and 99% of the sediment. But these two machines usually used by some big company. It's not for the personal use. Safety storage for aircraft use. Never use tank containing zinc, copper, or noise of those metal. Stainless steel or mine copper steel with appropriate coating is recommended for metal fuel storage tank. Use a folding suction intake system. Also use delicate type product unloading and receiving copper. And then in this tray, standard product marking on system component. Use watertight lock-able tank fuel cup and receiving couplet. Also use ring-proof and positive pressure. Safety storage for personal use. Kerosene does not produce explosion vapor like gasoline and diesel do, so that's much safe to storage and use. And you have to select plastic and metal container that is blue in color, and also have a tight sealing and produce ventilation. The fuel container should be kept close to the room temperature and always from sunlight, because sunlight and extension heat will break down the kerosene. Also, storage environment place, storage lock and keep a container tightly closed.
Kerosene was once widely used in households. In the mid-1900s, kerosene replaced whale oil as the commonly used lighting fuel in lanterns. Whale oil was very expensive due to scarcity, with prices ranging up to $2 a gallon. As we sped up into the electrical age, we began to use electricity in our lamps rather than kerosene. Kerosene is still used for lighting by people who live in developing countries. In India, my own home country, kerosene is subsidized, and the majority of people that have kerosene lamps in their houses use them for blackouts, which occur very frequently. The impoverished of India use kerosene over electricity because electricity is simply too expensive. Another example of people that use kerosene still are the Amish. The Amish avoid the use of electricity and therefore require kerosene for lighting at night. Kerosene in the kitchen. In some developing countries, kerosene is seen as a good alternative to electricity or gas in cooking. It's cheap and can be stored in the house easily. There are two main types of stoves that use kerosene: the wick stove and the pressurized stove. Pressurized stoves are expensive, and someone with the money to buy such a stove probably wouldn't use kerosene to cook. Careless use of kerosene can lead to fires, and if one uses a cheap wick stove, there is a possibility of it exploding. Another issue with using kerosene to cook is that it can lend its unpleasant taste and smell to the food that one cooks using it. Kerosene is also used for heating, and the issue with that is that kerosene is highly flammable and releases carbon monoxide, which is dangerous to human beings. Kerosene in cleaning. Kerosene has also seen use in the cleaning industry. Kerosene is potentially lethal to humans when we hang around it too much, and it has the same effect on bugs. It can be used as a pesticide to take care of a variety of irritating insects. One should be careful when using it, however, because it is not a good herbicide. When you spray kerosene onto a plant, it interferes with the plant's ability to photosynthesize, which kills the plant, and that is counterproductive. Kerosene can also be used as a solvent, lubricant, and a degreaser, with less risk of combustion than gasoline. Lastly, I'm going to talk about kerosene in entertainment. Kerosene sees a lot of use in the entertainment industry. Fire entertainers use kerosene because of its medium flash point, which means that the fire lasts longer than with other fuels. Kerosene is used by some fire breathers because it has a lower chance of a fiery blowback than the other fuels, whereas the dancers and jugglers use it because it leaves a small amount of residue on their toys, which burns up the next time they do their act, leading to longer overall burn times. The way fire breathers ply their trade is by actually spitting the oil out as a fine mist and then setting that mist on fire. This means that they are trapped under that mist, which is on fire, until it ends. Most fire breathers avoid kerosene for the same reason that some others use it. It lasts longer and burns well. However, if something goes wrong, there is no chance for a clean escape from it. Kerosene burns for longer, and therefore the mist that's burning above the fire breather would be burning for much longer, and they would be stuck under there. If anything goes wrong, it's the easiest way for them to get burned.
Hi guys, my name is Joel Luckenball, and I'll be talking about kerosene in military and aerospace applications. So the first fuel I'll be talking about is RP-1 fuel. Now, RP-1 stands for the Rocket Propellant 1 and is highly refined kerosene. It was the first fuel used to launch the Saturn V rocket that currently stands as the tallest, most heavy rocket to become operational. It towered at a height of 363 feet, and its storage tanks held 203,000 gallons of kerosene and 318,000 gallons of liquid oxygen. Now, these fuels were burned together over a burn time of about 17 minutes, and that varied through multiple stages of this rocket. Now, although RP-1 has a low specific impulse compared to liquid hydrogen, it costs a lot less, it's less explosive than hydrogen, which makes it safer, and it's stable at room temperature. In addition to being used in Saturn V, RP-1 has also been used in SpaceX's Falcon 9 rocket. The next fuel is JP-8 fuel. This is the most common type of jet fuel that's used by the Air Force in all the jet aircraft. JP-8 stands for Jet Propellant 8, and it also replaced the Air Force's JP-4 fuel. Now, both of these versions were introduced to replace diesel in various applications in the military. The fuel was first used as NATO's fuel for the different aircraft, and it's similar to Jet A1 fuel, which is used in commercial airliners. The major difference is that JP-8 has additives to inhibit corrosion and icing. They call this additive FSII, which stands for the Fuel System Icing Inhibitor Additive. Some of the properties of JP-8 include a flash point of greater than 100 Fahrenheit and a boiling point between 140 to 300 degrees Celsius. The vapor pressure is 0.029 pounds per square inch at 38 degrees Celsius. The next fuel is JP-10. JP-10 is the next generation jet fuel that's coming into the military. It boasts a higher energy density with a gain of 11% compared to JP-8. Just to compare, JP-10 holds 142,000 BTUs per gallon as opposed to 125,000 BTUs for JP-8. The major problem with JP-10 is that it's expensive to make, which limits the use of to surface-to-air missiles and what are called hypersonic jets called scramjets. The cost of this fuel is $25 per gallon. and in comparison to JP8, that's about $22 higher. The last thing I'll talk about is the MK77 firebomb. This is an incendiary bomb that replaced the napalm bombs in the Iraq War. They are used with a kerosene benzene gel that is contained in an aluminum bomb shell. It contains an oxidant that keeps the fuel burning and is safer on the environment compared to the napalm used in the Vietnamese War. This particular bomb, called the MK77 Mark 0 in the figure above, was the first version in use, and this bomb weighed about 750 pounds. Now, the Mark 1 through 5 models were only 500 pounds. These bombs were ignited at the front, where a fuse and igniter cavity would light about 1.25 pounds of white phosphorus. White phosphorus is actually the white version of phosphorus, which is actually used on matches. Now, match heads have red phosphorus, which just gives you an idea of how unstable it is once it's lit. So this chemical was very capable of lighting all of the fuel at once the bomb had ignited. The shell can hold about 75 gallons of the fuel, which after detonated will spread out over the surrounding objects and burn anything the gel sticks to.
Hi, good afternoon. My name is Ronaldo Springer, and today I'll be talking to you about the environmental impacts of kerosene production and uses in today's society. Kerosene, also known as a paraffin oil, is a flammable hydrocarbon liquid commonly used as a fuel. Kerosene is a mixture of multiple hydrocarbons. The main constituents are saturated straight chain and branched chain paraffins, as well as cycloparaffins. The molecular formulas of kerosene can range from C12H26 to C15H32, and upon combustion, like many other petroleum-based oils, produces carbon dioxide and water. As many of you may not know, kerosene has been used in today's society in forms of pesticides and insecticides. It has been primarily used to kill bed bugs and cure hair lice, but has become more common in the war against mosquitoes. Upon application of kerosene oil to contaminated mosquito waters, the kerosene acts as a barrier, preventing the exchange of oxygen from the atmosphere to the mosquito larvae, ultimately killing the larvae. But what are the consequences of this? Kerosene, being a middle distillate petroleum hydrocarbon product of intermediate volatility and mobility, is a combination of mostly lighter mobile compounds as well as heavier, less mobile compounds. The lighter, more mobile compounds are water soluble, quickly evaporating the atmosphere upon contact with sunlight and oxygen. They break down rather quickly. However, in groundwater, many of these compounds transition between solids, which are the soils, and liquid phases. The compounds in kerosene which are bound to solid particles will include polycyclic, aromatic hydrocarbons, and alkyl benzenes. These compounds tend to be in higher concentration within the soil rather than the groundwater, which makes cleanup processes challenging. Because when companies go out to clean contaminated groundwaters, they tend to ignore the soils around the waters, and over time these chemicals can seep back into the groundwater, and therefore the problem still exists. How significant is kerosene burning to environmental pollution? As you may know, light produced by kerosene lamps is extremely important for 20% of the world's population that lacks access to electricity. It's estimated that 77 billion liters of liquid fuel, mostly kerosene, are used annually to produce heat and light. However, an improperly adjusted, fueled, or poorly maintained kerosene heater will release pollutants through incomplete combustion. Black carbon, also known as soot, is a major pollutant from incomplete combustion. A study conducted by the National Institute of Environmental Health Sciences shows that 7 to 9% of kerosene burned in lamps becomes black carbon. Black carbon absorbs solar energy, which warms the atmosphere. Also, when it precipitates back to Earth, it darkens the surface of snow and ice. This results in a reduction of the albedo value, ultimately warming the snow and increasing the melting effect. But how significant is this 7 to 9% of soot produced by kerosene burning in the grand scheme of pollutants? Well, in comparison, only half of 1% of emissions from wood combustion is converted to black carbon. Inhalation of fumes from petroleum-based products may have some serious health consequences. In impoverished countries, people who burn kerosene for cooking and heating fires may inhale the combustion fumes. A study conducted by the Global Burden of Disease Study indicated that approximately 4 million people die annually from illnesses attributed to household air pollution due to the burning of petroleum-based fuels. Carbon monoxide is one particular product of kerosene combustion which can cause negative health effects. According to the Agency for Toxic Substances and Disease Registry, breathing the fumes from combustion of kerosene over an extended period of time could result in neurological and kidney damage.